Hi, this is Babak. In this video I'm going to solve the following problem for you. If I equals to 2 over pi multiplied by this definite integral, determine the value of 27 times I squared. This problem has been chosen from JEE Advanced Entrance Exam for Indian Institutes of Higher Education for Engineering and Technical Programs. That would be a good idea if you could pause the video at this point and try to solve the problem yourself first. If you do it right, then the answer would be 27I squared is equal to 4. Okay, now let me solve the problem for you. I will start by a lemma, which is a very well-known property of definite integrals, and that property is this. If I have a function f of x which is integrable on the interval from a to b, then this integral is equal to the integral from a to b of f a plus b minus x dx. How can I prove this one? It's easy. I will start from the right hand side. I would say let a plus b minus x be a new variable. Let me call it capital X. Then this becomes clear that the dx becomes negative of dx. A and b are constants. And then I know that when x goes from a to b, then this would imply that the capital X goes from b to a, yes? Because if little x is a, if I replace x with a, this a and that a will be cancelled, and b is left for me, and the same for the upper limit. Okay, so this means that the right hand side actually is equal to the integral. Instead of having from a to b, I will have the new, and the integral in terms of the new variable goes from b to a, and then I will have f. Instead of a plus b minus x, I just simply put capital X, and instead of d of little x, I will put minus d of capital X. Then of course I will use this negative sign to interchange these two limits. So this becomes the integral from a to b f of capital X d of capital X. But you know that the definite integral, the variable in the definite integral is a dummy variable, so I can replace it with any other variable that I like. So I replace it with x little x. And that's exactly the left hand side. Okay? So this is actually the most important point for solving this problem. Okay, how should I solve this problem? Here I will give this integral itself a new name. So let me call this integral itself j, and my goal is to calculate j, and then of course I will multiply it by this extra constant. Okay, so here the integrand for j, so I would say integrand so this misspelled. So integrand of j, let me call it f of x, and this is equal to 1 over 1 plus e to power sine x, and then I have 2 minus cosine 2x. Yes? Now my goal is to calculate f of a plus b minus x and see what happens. Of course, if I ask you what is a in this problem is minus pi over 4, the lower limit, and b is the upper limit, which is pi over 4. Okay, so therefore f of a plus b minus x becomes equal to f of minus pi over 4 plus pi over 4 minus x, which is actually f of minus x. And this means that I have to replace x with minus x everywhere in my integrand. So it becomes e to power. I need to replace x with minus x, but you know that that minus sign will go out from the sign, so it becomes minus sine x, and cosine is not sensitive to the negative sign at all, so it will remain the same because cosine of minus alpha is equal to cosine alpha itself. But I want to just manipulate it a little bit. I want to rescale this fraction by e to power positive sine x, meaning that I will multiply the numerator by this expression. I will also multiply the denominator with the same expression, but I will multiply this only in the first factor instead of multiplying it in the second factor. So then it becomes e to power minus sine x divided by this one becomes e to power positive sine x. The next one becomes 1, yes, because I am multiplying this expression by e to power positive sine x, so this becomes e to power 0, which is 1. And then I will keep the second one exactly as it is, so it's cosine 2x. Okay, so, but we know that j, according to this, let me make it a smaller so that you can see that. So this j is also equal to this integral. So I can write this is equal to integral from minus pi over 4 to pi over 4, the same a and the same b. But I would write f of a plus b minus x as the integrand, but I have already calculated and manipulated a little bit, so I will write this as my integrand, so it becomes e to power minus sine x. I made a mistake, this is not minus, sorry, this is positive because I multiplied everything by positive. Okay, so let me clean this one as well, so that is e to power sine x, sorry. And then I will have this denominator 1 plus e to power sine x 2 minus cosine 2x. And then I will have my dx. So what I have shown is that this integral j can also be written in this new form because of this lemma. Okay, now the trick starts from here. The point is to add this j and this j here, because they are the same thing, you will get two j's. So let me just do that, make it a little bit smaller here for you. So I would say j plus j is equal to, instead of the first j, I plug the original integral, so it becomes integral from minus pi over 4 to pi over 4. Then I have 1 over 1 plus e to power sine x multiplied by 2 minus cosine 2x dx. Yes, and then instead of the second j, I will write this one that I just got using this lemma. So this becomes integral from minus pi over 4 to pi over 4 e to power positive sine x divided by e plus e to power sine x multiplied by 2 minus cosine 2x dx. So now you see that I have two integrals added together, so you know that we have this rule. If I have integral from a to b of the f of x dx plus another integral from the a to b of g of x dx, I can write it as one integral and I can add the integrands. Yes, so I want to use the same idea. So this is the first function, this is the second function. I want to add these integrals. The limits are exactly the same, so I can use that. But on the left hand side I have j plus j, which I can simply write 2j. On the right hand side I can write minus pi over 4 to pi over 4. I need to add these two integrands, but the good point is that the denominators are the same, so the algebra is super simple. I just add the numerators and I will keep the denominator as it is. Yes, and then now the nice thing happens is this, that this is exactly this factor, so this will cancel out. And then what happens, this becomes equal to integral from minus pi over 4 to pi over 4 dx over just 2 minus 2 cosine x. Actually the hard part, the hard factor is now eliminated. And even, sorry, this is not 2 here. Okay, so that's just cosine. And then you know that this integrand now is an even integrand. So it means that if I replace x with minus x, nothing will change in the integrand, and this is symmetric with respect to the origin, so I can double the integral on the condition that I go from 0 to pi over 4. Yes, so this I can write it as 2 times integral from 0 to pi over 4 dx over 2 minus cosine 2x. Okay, but I want to calculate j, so I divide both sides by 2, so this 2 and this 2 will cancel. So what I get is that this j that I was looking for to calculate is equal to this a little bit simpler, much simpler definite integral. So let me write this on the next page. So we realize that j is equal to integral from 0 to pi over 4 dx over 2 minus cosine 2x. So I will spend my energy on calculating this one, and then you remember that this was the j integral. Okay. But this is not, this is a very standard calculation. So what I do, I just use the formula for the double angle for cosine. So this becomes dx. And then I will have 2, instead of cosine 2x, I would write 2 cosine squared x minus 1. And then this can be written as 0 to pi over 4 dx divided by 3 minus 2 cosine squared x. And then what I do, I multiply the numerator and denominator by secant squared. These are standard techniques, yes? So I will multiply the numerator by secant squared x. And what happens in the denominator, I will get 3 secant squared x. But secant squared multiplied by cosine squared becomes 1. So this is the case. And then hopefully you know that secant squared of x can be written as 1 plus tangent squared of x. Okay, so I will do this in the denominator. So I will keep the secant squared in the numerator as it is. But I will actually change this one. So let me just do it here. So instead of this, I will write 1. I would write 1 plus tangent squared. And then I multiply it by 3, so this becomes 3, this becomes 3, and then 3 minus 2 is 1. So I will get 3 tangent squared plus 1. So 3 tan squared plus 1. Okay? But now I will take square root of 3 tangent of x equals to a new variable t. Then I've differentiated, so it becomes square root of 3 secant squared x, because the derivative of tangent is secant squared, and then dx equals to dt. And now x goes from 0 to pi over 4. Let us find the new limit for my new variable. Okay, so if x is equal to 0, tangent of 0 is 0, multiplied by square root of 3 is also 0. And if x is pi over 4, tangent of pi over 4 is just simply 1. 1 multiplied by square root of 3 is just square root of 3. So then this integral can be written in terms of my new variable, but the limits are 0 to square root of 3. And instead of secant squared, x dx that you see here, I can simply write dt divided by square root of 3. So I would write 1 over square root of 3 dt, and in the denominator 3 tan squared becomes t squared plus 1. So this becomes 1 over square root of 3 integral from 0 to 3 d square root of 3 divided by dt divided by 1 plus t squared. But this is a very famous integral, so this is tangent inverse. So this becomes tangent inverse of t goes from 0 to square root of 3. I calculate this, it becomes square root of 3 tangent inverse of square root of 3 minus tangent inverse of 0. But tangent inverse of square root of 3 is just pi over 3. and tangent inverse of 0 is just 0. So the integral that I get, the answer that I get for j integral, this is this number. So j is pi over 3 square root of 3. This is the j integral. Okay, but what is the I integral now? So what is I actually? I is 2 over pi times j. So what will happen, this becomes 2, if I multiply this by 2 over pi, then this pi and that pi are cancelled, so I will get this is 2 over 3 square root of 3. Therefore, I am supposed to calculate 27i squared, so this becomes 27, but I squared is 4 over 27, so this becomes exactly 4 as it is mentioned in the problem itself. We are supposed to show 27i squared is equal to 4. I hope that you also enjoyed solving this problem as I did. This is why I shared the problem with you in the first place. I think there are very novel questions in those exams, so I will also start sharing some more problems from that exam with you. I will put the link to the PDF file of these notes below this video in the description. Until the next video, be safe and goodbye.